our keynote. This is another keynote speech of our platinum partners. It's a company, Rivian. I want to welcome the Jason Shiverick. He's a principal data scientist, and Venkat Sivasubramanian. He's senior director of IoT data analytics. Rivian company tremendously helped us in making this conference a reality, and this is just one step in our collaboration, and we hope that there will be many more of them. Rivian has an innovative data platform, which is a backbone for software-defined electric vehicles. This presentation unveils the platform's key role in advancing software-defined EVs, emphasizing its architectural principles and analytical potential for industry transformation.
Finally, okay, that's great. First of all, I was impressed that you were able to say my last name really well. Okay, and I'm also glad that you guys are all here when the lunch is out there, so that also shows that you guys want to learn, so that's great. So I'm super excited to be here today. Both of us are super honored to sort of present what Rivian's data and AI journey is and what we've gone through. I'm Venkat. I lead the Product Cloud Data and AI Platform Organization. And I joined the company about 2020, right amidst the pandemic. But fun to join a company that's focusing on first principles to build a vehicle and automotive. I grew up in the southern part of India, in Chennai, finished my master's, and then came to Minneapolis to work for Best Buy, the electronics retailer there. And then moved to San Francisco in 2011. And since then, I've been there, working on large companies and startups across different industries, but focusing primarily on data and how to bring value from data.
Hi, I'm Jason. I lead the data lake and AI components of Venkat's platform. I also started in 2020. It's been a super fun journey. And I grew up in the Midwest in the United States. I also lived in Minneapolis and moved to San Francisco. I think we overlapped for a while in Minneapolis. Great city. Also, San Francisco is a great city. You should come visit.
That's awesome. Okay. Rivian is a startup. What we want to do at a high level is to provide you guys what we do as a company, walk you guys through how our data journey has been, sort of what is the high-level architecture, maybe go a little deeper on our data lake architecture, and then walk you guys through some use cases to sort of bring everything together. Okay. Rivian is a startup that, it's interesting, it plays. Okay, that's great. So Rivian was started in 2009. RJ is our founder. You guys may have seen this amazing booth out there. Even though the company was founded in 2009, most of what we have built and what we will show today is being built in the last 3 to 4 years. We build these cool vehicles. The R1S is what you guys saw. R1T is the pickup truck. That's another vehicle that we build. We also build a commercial van, which we sell this to Amazon for last mile deliveries. All of these are really cool vehicles. Since the launch of these vehicles, we've won various accolades from premium institutions, including highest safety rating from IHS. With a software-defined vehicle, we'll talk a little bit more about that, and an incredible architecture, there is so much you can do. Right? Like you don't need a car specifically for commute, and maybe a sports car for the cool factor, or a car for off-roading. Right? You could get all of them in one with a click of a button. So let's see that in action. with different kinds of modes and what the software is able to do in terms of ride heights, changing the stability, changing the brake region, and all of that, right? So Rivian is a mission-driven company. Our mission is to keep the world adventurous forever. Part of that mission is to build amazing products, but also make them sustainable. The key for us is to build a future for our kids and kids' kids deserve by building sustainable products and inspiring our customers to also make sustainable choices. Automotive is going through massive transformation. Technologies such as autonomy, connectivity, electrification, edge computing are driving more and more of the innovation and software content today. Our vehicles are fully software defined, like I mentioned, and our deep OTA stack, which is the over-the-air update stack, allows us to update every single component of the vehicle. We can push software to all of the different ECUs. ECUs are these control units that are in the vehicle that allows us to update various things in the car, including vehicle controls, for example, infotainment, connectivity platforms, and so forth. Since the launch, we've been able to push lots of changes into the car, including things like camp mode, which auto levels the car when you're on an uneven surface, right? A snow mode that basically gives you better control when you're actually driving in the snow, right? Like, and a pet mode that allows you to leave your pets in the car while you're sort of busy shopping. We believe a critical part of being able to build such a machinery involves being able to leverage data and how you can be data-driven across the entire systems. We have over 65 to 70,000 cars in the road that actually sends terabytes of data to the cloud. We leverage these data to inform design, aid manufacturing, commercialization, and even sort of monitor the health of the fleet for service and maintenance. We categorize the data as it comes as what's vehicle core and what's not, and use techniques such as pseudonymization and anonymization before we provide access to end users. The picture here is a Rebel Rally picture. This is the Rivian team. It happened about a month ago. I mean, if you're not familiar, Rebel Rally is an all-women off-road competition where competitors basically drive in various terrains with old traditional navigation tools, right? Like, and Rivian actually won the first race, the first ever EV to win such a race. It was a proud moment for all of us. Okay. As a company that was sort of digital first and cloud native, there were several challenges for us to sort of get to where we are today. When we began our journey, we started with a clean sheet, but then the speed of innovation actually added so much more challenge for us. Lots of distributed cloud services means lots of distributed siloed data, right? Like, access becomes harder and harder. Democratization of data discovery and exploration needs to account for sensitivity and the privacy of the data. And rapid scale, we went from a few mules, which are like test vehicles, to pre-production vehicles, to validation prototypes, to production vehicles in a very short period of time. And not to mention the number of users that we had to onboard over the course of all of this. To tackle these challenges, we needed a solid platform and an architecture and an ecosystem to be built. This is sort of a high-level view of our landscape. The bottom portion is all of the data sets. This includes vehicle telemetry data, which is high fidelity, low fidelity data sets, service data, charging data, and so forth. The middle layer is our consumption layer, right? Like, we have got different components that powers different things. There is an analytical query component that allows us to query data, historical data, right? Like large volumes of data very quickly. And these are used via notebooks and other means by users. There is a near real-time streams and event processing component that allows us to tap into real-time streaming data as it actually comes in, and allows us to build stream processing application and streaming analytics application and so forth. That's also a layer where we actually do inference, model inference today. We also build multiple purpose-built data pipelines that allows us to create aggregated data sets that are pretty easy for our users to use. These are like data science users and so forth. And recently, we've also been working on a Gen AI platform. So how do we democratize Gen AI across the company? So what does that actually mean, right? we are toying around with a bunch of ideas across various use cases for the company, so that's something that's sort of top of mind for us. And the layer above that is all about democratization across the company, specifically focusing on our engineers and leaders. Our engineers can build their own dashboard and reports for most of their day-to-day purposes. Our data science folks and machine learning engineers can build their own models, manage their models, and depending on the use cases, they could actually push it to the car, to in-vehicle. I mean, these are examples like ADAS, diagnostics models that we push into the car, and so forth. We also have different applications that are built on top of all of this, right? Like fleet management applications that allows us to manage our fleet, specifically by fleet operators, like Amazon's operators that are basically looking at all of their vehicle fleet. And diagnostics application for engineers to be able to diagnose issues that are happening in the field. And applications that are sort of yard management. In the factory, when all of these cars come out, there is a need for managing all of the vehicles in the yard, right? Like those kinds of applications. And I'm calling about a few applications, but there are tons of applications that are being built on all of this. As you can see, the platform is broadly a real-time and a data lake platform. So that's how we've sort of built this. I'll now switch this over to Jason.
I'll go a little bit deeper into the two different components of our platform, which is the real-time streaming platform and the lakehouse, or data lake. The real-time streaming application platform is focused on bringing events into data from the field into the cloud in real time and providing mechanisms for processing that data in sub-second, low latency interactions. That gives us the capability to do fleet operations, fleet management, analytics on the fly, very powerful framework. We're processing, I believe, 1 trillion data points per day in that system. And I think I'll talk a little bit more about it, and then later this afternoon, Pi will give a talk more specifically about that platform. The Lakehouse platform that we built, where we are, one of the principles there are to have open formats and interfaces. Our primary data format is Delta, and we sit on top of Spark for most of our computation. That framework abstracts the storage layer and the compute layer to make the system very flexible. And I'll give more depth here in how we do that. So the real-time application, we use Kafka for streaming data, and we use Flink for processing on-the-fly data. It gives us a very powerful framework for managing data in low latency. And I think if you want to check out Pi's talk later at 5, if you're interested in the real-time streaming, it's going to go into more depth there. The Lakehouse platform we use to provide, I think right now we're sitting around 12 petabytes of data. Like I said, we built on top of Spark. We leverage Databricks and dbt for managing the data lake. Databricks is a big partner for us, kind of providing that platform layer that enables us to run with a fairly small team to administrate. And we scaled out to, I think, over 1,000 users right now. So I think it's a great platform for us. It gives people the tools to do data science, analytics, machine learning. It's built for data engineers, and they're kind of making things easier for every other discipline in this space. This is an architecture diagram, I think, that kind of goes into a little more depth in our platform architecture. So the vehicles, there's the Rivian logo, they send PCAP data, which is a packet capture binary data, up to the cloud into S3, and we consume it through a open source protocol in Go that we built that runs in Kubernetes. We decode all of that data, transform it into Parquet, and ultimately into Delta, and publish that back into S3, which then Databricks sits on top of those S3 buckets, providing the interactive query and analytics and machine learning layer that people can then process that telemetry data. I'll go through some specific examples on how people use this infrastructure. But I think one thing I wanted to point out is that we have a GitHub/Rivian open source repository that we're contributing to if people are interested in open source development. And we're building out a client for the Delta library in Go there. I think it's very exciting. Move on. So some of our consumers, I think, are the first end users of this platform. Autonomous driving, they use the data for modeling the self-driving system. They use it to identify things like phantom braking, build continuous monitors on top of that data to make sure that their systems are running well. The battery and charging systems, they use our data to understand the state of charge in the system, in the vehicles, how well are the charging systems working, is software draining the vehicle at night, like at what rate, how do we tune those things? And vehicle reliability is a big consumer of our data. They use it to understand the health and life cycle of our products across the electrical systems, mechanical systems, and make sure that we have good products throughout the life cycle of the vehicle. This is a slightly deeper example, I think a more visceral view of what the data looks like that we receive. It's mostly time series data in terms of the 12 petabyte data lake that we provide. It's all time series data. It's got sensor data like torque and voltage and current, accelerometer. Those kinds of things are very useful for mechanical engineers, electrical engineers to do deep dives into how the system is performing in the real world. So you can do, and reliability is a very good team at building like models, prognostics models, health monitoring models. So in this example, I think there's a couple of those sensors. If you look at that data, each one of those vertical bars is a second. So we have a huge amount of time series data coming in, and the modeling teams will do things like aggregate that data over time, and then across the fleet you can get an idea of like which vehicles are being impacted the most through aggressive driving or damaging driving, those kinds of things, charging behaviors. And using survival models, we can build future-looking like prognostics models and trying to identify which vehicles might fail for some specific reason first. And I think it's a powerful use case. So how do we improve the EV experience for our customers? I think I have one example here on charging. The vehicle controls team used our data to look into the parameters that drive the charging software, how quickly the vehicle can charge, how quickly it takes on charge, and how quickly it loses charge. And they were able to use our data sets to reduce the charging time it takes to get to optimal charge state by 13%. I think this slide is old, so I think they have actually improved it quite a bit more since then. But this is an example of how teams are using our data to make the whole experience, the software-defined experience, for our customers better. And because it's a software-defined vehicle, we push OTAs regularly. These changes that improve the customers' lives can be pushed over the air. It's a very powerful paradigm to have a software-defined vehicle that's data-driven. So here's takeaways. I'll let Venkat talk about this.
So yeah, I think that's largely a wrap. At Rivian, we believe sustainability is no longer an option, but a necessity. Together with partners and alongside with other EV manufacturers, we aim to work towards a future that's efficient, eco-friendly, and inspiring. Data democratization is really key to unlock innovation. We need to build modern tools and frameworks in order for non-data engineers, I'm talking about mechanical engineers, hardware engineers, and other sort of software engineers, to be able to navigate, explore data, build their own insights for what they care about. Keeping the data at the center, advancements in data processing, machine learning, and AI can truly bring a step change in experience for our end users. I think with that, thank you all for staying together when there is lunch. I truly appreciate that. And of course, as Rivian is huge and becoming large at Serbia, we are always hiring engineers, data scientists, folks, and leaders. So if you're interested, please reach out to us. Of course, we have a booth, and there's a talk coming later today from Pi. Thank you all.
Thank you guys for your amazing talk. If there is questions, we still have time, of course.
Thanks for the interesting information. Do you have car-to-car connectivity on based on geolocation, maybe sharing specific data between the cars?
That's a great question. Car-to-car connectivity without cloud? That's what you mean? Or like in general? So
in general, I mean.
In general, there are underpinnings in the car today that can allow a car to connect with another car, but we don't have a capability yet built on top of that technology. So there are ways in which a car can actually connect to the cloud, and through the cloud, we could actually connect multiple cars. And there are also NFCs that are there in the car that actually allows us to exchange. For example, if you're on your mobile app directly talks to your car, right? So that capability exists, but we've not sort of explored any features today for car-to-car interaction as yet. Yeah.
Thank you.
No worries.
Thank you for your presentation. And my question is, are you working on some autonomous driving solutions right now, or you plan to work on those?
Do you want to take? So we are, absolutely are. We do have a level 2 autonomy support in the car today. It's somewhat basic, but we are actively investing heavily on that to sort of really get to higher orders. So yeah, there's tons of investments happening there.
As a techie, I would have a more technical question. I heard in a lot of conference presentations, also in yours, about DBT, and you mentioned that you're using it within your architecture. How and for which purpose are you using it? I think it's partly an orchestration tool, if understood correctly.
Yeah, DBT I see as kind of an orchestration layer for the different pipelines that run through Databricks, and kind of an organizational layer to enable like a good catalog management, data lake management, and CI/CD kinds of things. Right? So it's I think of it as infrastructure as code for SQL. That's kind of how we use it.
Okay, thanks a lot. Would be great if we can have a deeper talk later, as we're also using Databricks and Lakehouse in Unity Catalog. Awesome, thank you.
I want to thank you once again on behalf of organizing team for helping us in making this conference reality. I have certificates of appreciation for your engagement and conference, and we hope to see you again to speak about this very interesting topic.
Thank you.
We will be back in this room at 15 o'clock, so you have a long break to eat and to come back keen to learn and ask.